Principal at a very large high school claims the students spend at least 10 hours per week doing homework. Same type of questions as before from the notes yesterday or connected to this. We've got a sample of 250 students from a very large high school. 10.2 hours is the sample mean. Sample standard deviation is 4.2. So I think we talked about this already. What's the population? High school students. And what are we kind of measuring? The time, the parameter that we're measuring is the time spent on homework. Checking this condition, we want to make sure, does it say random somewhere? Because we can't really do this with skewed data, seeing we're trying to find the middle section. And it says random sample up at the top. You want to check to the 10% rule. If it's a really large high school, then it's possible that 250 students, that should be 10% or less. It's not saying just seniors or anything like that. A very large high school could very well have 2,500 people. So I would say that the 10% rule is there. You don't get to just say no and then not do the problem. So when in doubt, we'll probably calculate it. The problem with this one is there's no NP greater than 10 because we don't have a proportion. So we can't solve something like that. The thing that we want to double check to make sure that it's approximately normal, we want to look and see, does it say somewhere in here that it's normal to start with? Sometimes it'll say like it's distributed normally. It doesn't say that. Okay. So the other way to check is the central limit theorem, which says we've got to take a sample size of 30 or more. So we're taking a sample of 250, that's fine. Degrees of freedom, if there's 250 people in our study, then there's 249 degrees of freedom. So you want to look at that chart. We're going to do a 95% confidence interval, and we're going to pick 100, and we talked about this before for the degrees of freedom. Because there isn't obviously 249 and we want to go closest without going over. So 100 was the closest without going over. And if you look in the sections over here above 95%, I thought we read off 1.984. So that's going to be our T value. Now to do our confidence interval, it's going to be the same exact way that we were doing before, where we're trying to find the middle 95%. Now be careful, we don't just do positive or negative 2 standard deviations away from the mean. We're not going to do that because this is using a T interval now. So we have to make sure that we're using 1.984 for our 95% confidence interval. It will change it just a tad. It's the same type of rule where we've got 10.2 hours in the middle, and we want to go 2 standard deviations up, would give you that 95%. So technically about 2 standard deviations up, we're going to call it 1.984 standard deviations up. So the trick is first finding what the standard deviation is, and this is the sample standard deviation divided by the number of people in the study, square rooted. Plug in 4.2 for the standard deviation that was given to us. And I'm getting 0.26561. So if that is 1 standard deviation away from the mean, we need 1.984 standard deviations away from the mean. which is going to give us about 52.527. So I've got to take my mean, and I want to go up by 0.527, and I want to go down by 527. Gotta fix that. So around 10.73 to 9.67 is our confidence interval. It looks a little bit different than before. Before we really had decimals, and we were supposed to have a proportion, so we shouldn't have really had a number bigger than 1 for the last ones. For these ones, we are giving kind of where we feel the true mean is going to be. So our conclusion is set up the exact same thing as before. We are 95% confident that the interval from, and I always give the smallest to the largest, to captures the true mean number of hours, and we were testing the studying or the homework that students at this school spend doing homework. So it's very, very similar as sample proportions, but the big thing is using a t-score for mean versus a z-score for mean. And the same thing with these standard deviation, that's also a little bit different as well. But the same basic idea is there.